Hello everyone, welcome back. We learned so many things about rational numbers. We already learned on the operations on the rational numbers and everything, right? Today we are going to talk of the properties of the rational numbers. Now, why we need to understand them? So, these properties are really useful when you do the calculations on rational numbers, right? Operations, basically. So, we are always looking for some easy methods, right, to solve some problems. So, here these are the properties which are very basic, but yet they are very useful in calculations. They make our calculation very simpler. So, now let's understand. So we'll start with the closure property of natural number. Now what do you mean by a closure property? So when you add two natural numbers, so always you will get a natural number, right? So that's a closure property of the natural number, I can say. So let's say if I'll say 5 and 4, if I add them, I'll get 9. So 9 is also a natural number, right? So this is the closure property. Now when I talk about multiplication, that is valid again. So 5 times 4 if I'll do, I'll get 20. Okay. But now in terms of subtraction, it may or may not be a natural number. So how it is? So let's understand. So 5 minus 4, I'll get 1. But if I say 9 minus 10, then it is not the whole natural number, right? It is the integer value, correct? So this subtraction, the closure property for natural number is not valid. Same thing for division, it is not a natural number always. So if I'll say 10 divided by 5, correct, so I'll get 2, which is a natural number. But if I'll say 1 divided by 2, then we'll get 0.5, which is not the natural number, correct? So the closure property is valid for addition and multiplication of natural number. Now we'll discuss the closure property for the whole numbers. So again, it is valid for addition and multiplication, but it is not valid for subtraction and division all the time. So again, let's understand with the numbers. Now whole numbers are what? 0. So if I'll just consider 5 plus 0, so I'll get 5. Okay. So I get the natural whole number again. Correct. 5 is a whole number. Or if I'll say 10 plus 5, I'll get 15. These are whole numbers. But for subtraction again it is not valid. So let's say if I'll say 0. 0 is a whole number. And if I subtract 2, so I'll get negative 2. So which is not a whole number. It is an integer value. And same thing for division. 0 is the whole number. If I'll divide by a whole number, I'll get 0. But if I'll take vice versa, let's say if I'll take 5 and divide by 0, they both are whole numbers. But this answer is not a whole number. Correct? So this is not, it is not defined itself, right? So for closure, I mean the on whole numbers, the closure property, addition and multiplication it is valid, and subtraction and division it is not valid. Now closure property of integers. So if I'll take any two integers and if I'll add them, let's say negative 2 and positive 5. So if I'll add them, I'll get 3, right? So that's a closure property. It's a integer value, right? Same way negative 2 times 3. So what do we get? Negative 6. This is the integer value. Negative 1 minus 3. So I'll get a negative 4. So this is the integer value, right? But in case of division, let's say negative 3 divided by 0. So we won't get the integer value, right? This is not defined. So this is not valid for division, correct? So this is the closure property which is valid for addition, multiplication and subtraction in case of integers and not valid for division. Alright? Okay. Now closure property of rational numbers. So see, this all natural numbers, integers, whole numbers are rational numbers. Okay. So I can write those numbers, but to get it more clear, I'll just write, let's say, half. And I'll say 3 upon 2. So if I'll add them, what do we get? I'll get 4 over 2, which is just 2. So this is also a rational number. Correct? To multiply them. So let's say 1 over 2 times 3 over 2. So what do we get? 3 upon 4. This is also a rational number. I can take any negative number also. Let me just take for negative. 1 half and plus negative 3 and a half. Sorry, I have to subtract them. So I'll just take a subtraction here. Okay, I'll just subtract them. So what do we get? This is negative 1 half and negative negative positive we learned already in terms of operations. So I'll get negative 1 plus 3, which is 2 over 2, and my answer is 1 for this, correct? So this is the rational number. In case of division, if I think about 0, then it is not defined. So this is not closure property. Let me write 1 half divided by 0. So this is not defined, right? This is not defined. So closure property is valid for addition, multiplication and subtraction in case of rational numbers. Alright. Now commutative property. So commutative property is what? Changing the order. Means what? Now we'll think about the natural numbers. Okay. So first if I'll say 5 plus 3. So the answer is 8. And if I'll change the places. Okay. 3 plus 5. If I'll change the order, then also I'll get 8. In case of addition, this is valid. Correct? Now in case of multiplication also, if I take any two natural numbers, let's say 2 and 3. If I'll multiply them, I'll get 6. And if I'll change the order, 3 times 2, then also I'll get the same answer. Correct? But is it valid for subtraction and division? Let's check. So 5 minus 3 is positive 2. But if I'll change the order, I'll get 3 minus 5. So which is minus 2. So they are not same, right? And same thing for division. So let's say 5 divided by 3 and 3 divided by 5. They are not same, correct? They are not equal. So commutative property is valid for addition and multiplication in terms of natural numbers. I hope you get it. Okay, now commutative property of whole numbers. So you can easily understand. For addition it is 2. So let's say 5 plus 0, I'll get 0 plus 5. They are both are same. Correct? Any two multiplication 1 times 5 and 5 times 1. They both are same. Correct? Subtraction again. If I'll say 10 minus 9, which is not equals to 9 minus 10. Commutative is not valid for subtraction and division also. We already understood that, right? Okay. Now for integers. So what will happen? So let's say 5 plus minus 3. So what do we get? 2. If I'll change the order, minus 3 plus 5, I'll get the same answer. So for addition, it is valid. Same way for multiplication, if I'll take any two integer value, I'll get same answer. If I'll change the order also, I'll get the same answer, right? Minus 3 into minus 2. So we'll get 6 only. So for multiplication, it is true. Now what if I'll do the subtraction? So let's understand. If I'll say 5 minus 3. Okay, so what do we get? Here in this case, I'll get 8, right? Now, if I'll change the order, so minus 3 minus 5. So here I'll get minus 8. So they are not equal, right? They are not equal. So just understand this. For subtraction, it is not valid commutative property, and for division also. Think about 0, okay? If I'll divide any number by 0, 10 divided by 0, that is 0 divided by 10. If I'll change the order, this answer is 0, right? This answer is 0, but this is not defined. So for division, it is not commutative, correct? I hope you understood this. Now, in case of rational numbers, what will happen? Let me take negative 1 half plus 3 over 2. So what do we get? We'll get 1, right? If I'll change the order, will I get the same answer? Yes, 3 upon 2 plus minus 1 half. Then also I'll get answer 1. So for addition it is working. Same way for multiplication it will work, right? So let's say 1 negative 1 half negative 3 half. So what do we get? It is 3 upon 4. And if I'll change the order, I'll get the same answer. Correct? So the commutative property works for multiplication of rational number also. What about subtraction? So negative 1 half, negative, negative 3 and a half. So what do we get? This is a positive, so this will be 1. But if I'll change the order, negative 3 and a half minus minus 1 half, do I get same positive 1 answer? No, I won't. So for subtraction, it is not valid. Correct? This answer is minus 1 here. And for division, the same reason, right? Okay. Now associative property. Associative means grouping of the number. So let's understand. So if I say 2 plus 3 plus 5. So what do we get here? I'll add these numbers first and then I'll add to 5. So 5 plus 5 I'll get 10. If I'll change the group, so 3 plus 5 first I'll do, which is 8. 8 plus 2 I'll get 10. So in case of any grouping, okay, I'll get the same answer in case of addition. So this is the same case for multiplication as well. So let's take 2 times 3 times 5. What do we get? 15. 15 times 2 is 30. If I'll take the order 2 times 3 times 5. So 6 times 5, which is 30. So I'll get the same answer. So multiplication, natural number. Associative property is valid. In case of subtraction, it is not valid because commutative is also not valid, right? So here also you won't get the same answer. Let's understand. 2 minus 3 minus 5. Okay. Here you won't get any natural number. So anyway, the subtraction is not valid only. And for division, so this is not valid, correct? Okay. Associative property of whole numbers. So same way, right? You can easily prove for addition and multiplication they are valid, and for subtraction and division they are not valid, correct? Okay. Now associative property of integer. So let's understand by taking some integer value. Minus 2, okay, plus minus 5 and plus 3. I'll take these three numbers and then if I'll make a group of these two first. So minus 7 plus 3, I'll get minus 4. If I'll change the group, so negative 2 plus minus 5 plus 3 if I'll do first. Okay, I'll take this group first. I'll get negative 2. So negative 2 plus negative 2, I'll get negative 4. So I'll get the same answer for addition. Same way you can prove for multiplication. But it is not true for subtraction. You can take the same example. Let's say minus 2. You are subtracting negative 5 and you are subtracting then 3. So what do we get here? 2 and then minus 3. So this is negative 1. Now if I'll change the group, so what will happen? Negative 2 minus, now I am changing this group to negative 5 minus 3. So what do we get? Minus 2 minus minus 8. So this gives me a 6, right? So see, these two answers are not equal. These two are not equal, correct? Okay, and same way you can prove for division. See, for division it is easy if you take 0, right, to prove it. Alright. Now associative property of rational numbers. So let's understand. I have 1 half plus negative 3 and a half, and then if I'll add that answer to 5 and a half. So what I'll get? This is negative 2 over 2, which is negative 1 plus 5 over 2. So what do we get? 3 over 2. Is this the same case? If I'll change the order, let's check. Group. Okay, so 1 half and I'll add negative 3 over 2 plus 5 over 2 first. So I'll get 1 and then 1 half. So it is 3 over 2. I'll get the same answer, right? Same way you can easily prove for multiplication. It is valid. Now let's check for subtraction. So I'll just take these numbers only. I'll subtract them. So negative, I am subtracting negative 3 over 2. 3 over 2 and then I'll subtract 5 over 2. So what will happen here? First of all, if I'll take this group. So I'll get negative, negative, positive. 3 plus 1, 4 over 2. 2 minus 5 over 2 and that gives me negative 1 half. Is this the same answer? When I take the other group, let's say 1 half minus negative 3 over 2 minus 5 over 2. So here I'll get negative 4 and negative, negative, positive 4. So what do we get? 1 half plus 4, this gives me 4 and a half, which is 9 over 2. So they are not same, right? So for subtraction it is not valid, and same way for division also you can prove easily, right? Okay. Now distributive property of integers. Okay. Now multiplication over addition. See what it is. Let's understand with one example. So I am taking three integers, let's say 2, negative 1 and negative 3. Okay, I am taking these three integer numbers. Now I'll write this distributive property. So if I'll say 2 minus 1 plus minus 3. Okay, I am doing this. So let's solve this first. So what do we get? 2 and negative 1 plus negative 3 is negative 4 and I'll get negative 8. So keep this aside. Okay, now I'll just do a into b and plus a into c. So see, this is my a, b and c, three numbers. Huh? So a into b. So 2 into minus 1 plus 2 into minus 3. So what do we get? Negative 2 plus negative 6. So I'll get negative 8 again. So this is distributive property for integers. Okay. Same way I can prove for subtraction also. Alright. Okay. Now distributive property of rational numbers. This is very much important property to understand. Now same way. Okay. If I'll take these three values for a, b and c. Let's say I am taking 1 half. Okay. Negative 1 half. And I am taking this as 3 over 2. So I have taken these three numbers. Now I'll do this first. A plus a into b plus c. So minus 1 half plus 3 over 2. If I solve this, so what do we get? If I solve the bracket first, I'll get 1 and 1 into 1 half, I'll get, see, I'll write this. So I'll get negative, positive 1 half. Now, if I do a into b first, so 1 half into negative 1 half plus 1 half into 3 over 2. So what do we get? This is going to be minus 1 over 4 plus 3 over 4. If we solve this, I'll get 2 over 4, which is 1 half. Correct? See, in both cases, we'll get the same answer. Correct? And same thing I can prove for subtraction also. Alright? Perfect. Now, identity element. So, 0 is called the identity element for addition. We already learned that, right? So, that means what? If I'll add any number, if I'll add 0 to any number, I'll get the same number, right? So, let's say 3 over 2 plus 0. I'll get 3 over 2. So, 0 is called the identity element. Same way, 1 is the identity element for multiplication, because if I multiply any number by 1, then I get the same number. Correct? So 1 is the identity element of multiplication. Now I hope you understood these properties. So let's solve some questions based on them. Alright? So solving some questions. Now see, as you just observe this, these are very easy to solve. Okay? Now just understand, can I apply the associative property here? Yes, I can. So first of all, if I solve this, 1 half minus 1 half plus minus 3 over 4. So what do we get? This is going to be cancelled out, 0. and then my answer is just negative 3/4. Correct? So we solved this first. We applied the associative property. So you have to write that, okay? Associative property we applied. Alright. Now let's solve the second one here. Now see, if I'll just see this negative 1.3 and negative 0.7, and then if I'll add 4.5, see, write the sign which is just in front of the number. So here we'll get negative 2 plus 4.5. We applied the associative property. So please write everything, okay, which property we applied, and we'll get 2.5. Perfect. Very easy, right? And these two numbers I'll associate. So negative 2.7 plus negative 1.3 plus 1/2 plus minus 1/2. Very easy to solve. We applied the associative property. Okay, associative. So I'll get 0 here and negative 2.7, negative 1.3. So what do we get? We'll get negative 4. Very easy to calculate, isn't it? No need to take LCM and solve, okay? Alright. Now by the time you understand that, see, denominators are same. So I can apply the associative property again. Okay, so what do we get? 17.25 minus 7.25. I am taking this number along with this, associating, plus 5/6 plus 1/6. And now very easy to calculate. What do we get here? 0.25 will get subtracted and I'll get just 10 here, and here I'll get 1. So my answer is 11. Isn't it very simple to calculate? Yes, it is. Alright. Now we have to solve this by using appropriate properties, and we have to mention which property are we using. Now let's understand, let's observe the number. See, I can see 3/5 and 3/5 here. Correct? For this two. So what I'll do, I'll just write them first. So negative 2/3 into 3/5 minus 3/5 into 1/6 plus 5/2. See, once you are comfortable now, you can do this mentally. So if we observe the number, what do we understand here? This is 3/5 and 3/5, which is common here, right? So what I'll do, I'll just write them together first. So negative 2/3 times 3/5, negative 3/5 times 1/6, and then 5/2. So we applied the commutative property. I have changed the places of these two. So commutative. Okay. Now I apply the distributive property. So how to apply? I'll just take this common number. So 3/5 is common. Now see, you have to write the sign along with the number. Okay. So here minus 2/3, then minus 1/6, and then don't forget to write this 5/2. Okay. So we apply the distributive property. And now we'll solve this. So 3/5, and then if I'll take the LCM and simplify, I'll get minus 5/6 plus 5/2 is there. Okay, so simplify. And now when I simplify, 5 get cancelled out, right? 3 ones are, 3 twos are, so I'll get negative 1/2 plus 5/2. And then we can easily simplify this. So 5 minus 1, I'll get 4. 4 upon 2 is just 2 is my answer. I hope you understood this, correct? Okay. Now let's solve the second one. So again, if I'll observe the number, Here 2 over 5 is there. 2 over 5 is there. Correct? So what I'll do, I'll just use the commutative property first and I'll write them. 2 over 5 times negative 3 over 7 I'll write. Then plus 1 over 14 times 2 over 5 I'll write. And then this remaining number, okay, minus 1/6 times 3 over 2. So we apply the commutative again. Write this properly. Now distributive. So 2 over 5 is common. Write the numbers which are left with the signs. Okay. Plus 1/14 and then simplify this number. So what do we get? 3 1 times, 3 2 times. So I'll get negative 1 4. I have simplified this last term. Okay. So I applied the distributive property. Write the whole property. Okay. Now what do we get? 2 over 5. If I'll take the LCM and simplify, I'll get minus 6 plus 1, which is minus 5. So negative 5 over 14. And here I'll get negative 1/4. Then if we simplify this again, so 5 will get cancelled out. And I'll get negative 1/7 minus 1/4. And you have to simplify by taking the LCM. So what do we get? You have to add 7 and 4, negative 11 over 28. So this is my answer, right? Perfect. Now here we have to mention which property is used to solve this. So if you observe these numbers, the places are interchanged, means commutative property, right? Now tell me which property is used. Yes, if you see the group is changed, right? See, number of the numbers are same as it is, only the brackets place is changed, means associative. Okay, and then here again the numbers are interchanged, means commutative. Now tell me which property 0 is added, also the commutative and the identity element. So here two properties, which are there? Commutative and identity element. So 0 is identity element of addition. Correct? Okay. Now see, the numbers are same as it is, only the brackets are place is changed, means associative. It is very much important to identify. Okay. Now multiplication by 1 and you'll get the same number. So commutative and identity element. So 1 is the identity element of multiplication. I hope you understood this. Now tell me which property. See, multiplication sign and addition sign, and then the numbers are written this way. So yes, distributive. Very good. And here also distributive. This is distributive multiplication over addition, right? This is multiplication over addition. And the next is distribution multiplication over subtraction. Correct? Perfect. Now sum of two rational number is a rational number. Which property they are talking about? Yes, very good. Closure property. Right? Okay. Now here we have to solve these questions using the distributive property they mentioned here. Right? So if I'll observe the numbers, which number is common? Yes, 7 over 5. So I'll write 7 over 5, and then whatever is there I have to write in the bracket. So negative 3 over 12, use a plus sign, and then 5 over 12. Now it is very easy to solve, right? What do we get? 7 over 5, and when I simplify we'll get 2 over 12, which is again simplified 1 over 6, and then my answer is 7 over 30, right? Perfect. Easy to solve. Now which number is common? 9 over 16, correct? So I can say 9 over 16 is common, and now what is left here? Write the number with the sign. So 4 over 12 plus negative 3 over 9. Now before I'll take LCM and all, can I simplify those number itself? Yes, I can, right? So what do I get? 4 over 12 is 1/3 plus this is also negative 1/3. Easy. What is the answer? This is 9 over 16 times 0, and the answer is 0, right? So see, by applying the properties, the question is very easy to solve, isn't it? So I hope you understood the properties, right? Students are facing a lot of difficulties when they solve this properties question. So I request you to watch this video, solve along with me, try to understand all the properties, and let me know if you have any doubt. I'll just try to clear all your doubts. And thank you for watching this.